Chapter 9.6 Variation. Okay, for this section, we will learn two types of variation. One is direct variation and the other one is inverse variation. So the equation of the direct variation is this: y equals k times x. So k is multiplied by x, and the inverse variation is y equals k divided by x. This time k is divided by x if this is inverse variation. So whenever we have a sentence like this, y varies directly as x, directly. So if we have a directly as x, then multiply k. Okay, k is called the constant of variation. So multiply this k by the expression comes s, after s. So the expression is x. So multiply k by x. Or if we have a sentence like this, y is directly proportional to x, then multiply k by x. So y is directly proportional, then y is equal to k times x. Can multiply k by x directly. Or inverse variation is this. You divide k by the expression if you have inverse. So y varies inversely as x. Then y is equal to k divided by x. If you have the word inversely, then divide k. Or if you have if a sentence has y is inversely proportional to x, inversely proportional, then divide k also. So y is equal to k divided by x. So there are two types variations. One is direct variation, the other one is inverse variation. So there are two equations: y equals k times x, or y equals k divided by x. So we have to find k, the constant variation k. So always the values of x and y will be given because we need to find k, always. So for the example 1, find the constant of variation if y varies directly as x. Here's the word directly. So this is a direct variation. So we can write an equation. Y varies directly as x. So y is equal to k times x, not k divided by x. This is a direct variation. And the values of 35, x and y are given. Always the values of two variables, x and y, are given so that we can find k, the constant of variation. So let's plug in those two values. Y is 35 and x is 5. So from this, k is equal to 35 divided by 5. So k is equal to, from this, k is equal to 7. So just plug it back to the original equation. Y is equal to now what? K equals 7, right? 7. So y equals 7x. So this is the equation for this direct variation. So from this equation, if x value is given, then you can find y. If y is given, you can find x. So always, for the direct variation and inverse variation, write an equation first, and then substitute those x and y values so that you can find k. Okay, for problem number 1, try this one. All right, find the constant of variation if p varies directly as x. So here is directly as x, so this is direct variation. So we can write an equation. P is equal to, direct variation, we gotta multiply k by q. So this is an equation, and let's find k. And the values of p and q are given. P is 120 and q is 8. So from this, k is equal to 120 divided by 8. Then k is equal to 15. So now substitute this 15 for the constant of variation k. Then p will be 15q. So that's the equation of this direct variation. All right, for this example, okay, the amount A is directly proportional, directly related to something, to a person's weight. So this is direct variation, so that the equation will be y is equal to, no, not y, the amount A. A is directly proportional, so A is equal to K times what? The weight. So from this one, okay, the weight is 50 kilogram and 2 milliliters of medication are required. So this will 2 milliliter will be the amount of medication. Then how many milliliters are required for 75 kilogram person? So in order to find this one, let's find K first, because from the first example, first sentence, A and W are given. The values are given. So from this, we know that A is 2 milligrams, milliliters, and then B, not B. And then the weight of a person is 50 kilogram. So let's substitute these values for A and W. So the amount of medication, 2 milliliters, is equal to K times the weight of a person is 50 kilograms. So from this one, K is equal to 2 over 50. So K is equal to 1 over 25. Reduce, so 1 over 25. So we have an equation. So from this one, we have an equation. A is equal to KW. So A is equal to K is 1 over 25 W. So this is the equation. Direct variation equation. Now let's answer the question. How many milliliters? So we want to find A. Okay, how many milliliters? So that is, let's find A, right? Let's find A from the equation. And 75 kilograms of a person. The weight is given. So from this, A is, so we want to find A. We want to find A. And then W is what? From here, W is equal to 75 kilograms. So plug it in here. And then A is equal to, okay, reduce it, that will be then 3. So the amount of medication is 3 milliliters. So that will be 3 milliliters. Okay, problem number 2. Okay, try this one on your own. All right, the total weight of a nurse is directly proportional. Directly, so this is a direct variation. Directly proportional to H. So we can write an equation. W is K times X, K times H. Okay, H represents number of hours worked. Okay, now a nurse earns $264. So this is the wage. So 264 is the wage. And then for working 12 hours. So this is the number of hours worked. So in that case, we can find the K first. So in this case, W is given, which is 264, and H is 12 hours. So this is 12 hours. All right, so let's find K. So W is 264, and H is 12. So 264 divided by 12 is equal to K. Then K is 22, isn't it? 22. 24, so 24 is 22. Okay, this is 12, isn't it? 12. So from this one, let's plug it in. Then the function, the equation will be W is 12H. So this is the equation. And from this, we want to find what is the nurse's total wage. So we want to find the wage. We want to find the wage when the nurse works 18 hours. So now Let's plug in 18 for H. So, okay, so from this one, W is equal to 12 times what? H is 18. So, in this case, H is 18, so plug it in here. Then W will be equal to, all right, let me calculate this. And this is 216. So the nurse will earn $216 for working 18 hours. So the answer will be $216. Sorry about this. This is $22. Case 22. Why is it case 22, right? 22. So this is not right. So K equals 22. 264 divided by 12 is 22. So we have an equation W equals 22H. So 22 times H, which is 18. Then 22 times 18 is 396. So the total wage for the nurse is $396. Okay, example 3. Okay, find the constant of variation K if Y varies inversely as X. Look at this. This one is inversely. So this will be inverse variation. So let's write an inverse variation. Y varies inversely. So K this time divide K by X. And then the values of Y and X are given. So from this one, let's find K. And the value of Y is 30. K is 10. Then multiply each side by K, by 10. Then 3 times 10 is K. So K is equal to 300. So plug it in the equation. Then this will give us the equation Y is equal to 300 over X. Or you can write it as Y is equal to 300 times 1 over X. But just leave it as this one. So that's the equation of inverse variation in this example. Problem number 3. Okay, pause this and then try finding the constant variation K. All right, S varies inversely as T. Inversely, so this is inverse variation. So the equation will be S is equal to K divided by T. Now divide K. All right, and then the S value is 12, and then T equals 8. So S is 12, K divided by T is 8. Then multiply each side by 8, then K. So from this, K is equal to 96. So put it back to the original equation. Then the inverse variation, the equation for the inverse variation is S is equal to 96 over T. So this is the equation for this inverse variation. Okay, for example number 4. Okay, the volume of a gas varies inversely as X. Varies inversely with the pressure P. So this is inverse variation, and the volume is 300 cubic centimeters when the pressure is 20 pounds per square inches, PSI. So from this one, we can write an inverse variation equation. So the volume is inversely proportional to K divided by the pressure. So that's the equation. And then P and V values are given. So V is 300 and P is 20. So from this, 300 multiply each side by 20. Then K is equal to 6,000. So plug it in the original equation. Then our equation, the inverse variation equation will be V equals 6,000 over P. So this is the equation of the inverse variation. Now we want to find the volume V when the pressure is 80 psi, pounds per square inches. So from here, P is given. So we'll replace this P with 80 psi. Then V will be 6,000 divided by 80. Then V will be equal to, that is 75. So the volume will be 75 watt. This is, the volume is centimeters, so cubic centimeters. So that's the volume of this cylinder, automobile cylinder. All right, the number of hours H that to complete a daily quota is inversely proportional. Inversely proportional to the number of assembly machines. So if there are 5 assembly machines, then the number of hours to complete the daily quota is 9 hours. So it takes 9 hours to complete. So from this one, we can write an inverse variation. So the number of hours, so H is equal to K divided by inversely. So we have to divide it by the number of assembly machines. And in this case, the values of M and H are given. So let's find the constant of variation. So H is 9. It takes 9 hours if there are 5 assembly machines. So from this one, K is equal to, multiply each side by 5, then 45. So plug it in here, and then the original equation will be H is equal to 45 divided by the number of assembly machines. So this is the equation. Okay, let's check the question. Okay, how many hours does it take for 4 assembly machines? So this means M is equal to 4. So from this number, we can find H. So H is equal to 45 divided by 4. Then this is equal to what? 11 point something. So 11 and 1/4 hours. So 11 hours and 1/4 is 15 minutes, isn't it? So 11 hours and 40 minutes, 15 minutes.